Hello, hello, hello. How are we doing, guys? Are you ready for a build battle? Right, you've got a couple of minutes to sort yourselves out because I forgot I need some of these things. Obviously. Oh, right. My lesson actually went really well this morning, so I'm just gonna chill about the fact that I'm really disorganized about other things in my life. Feel free to like and subscribe whilst you're waiting. Say hi. I've put a post on Facebook if you want to make some comments. Say hi. Nice comments, please. What I think of that. Yes, I have. Yeah. Oh, good. Oh, good. We're having one of those days. I'm going to untangle this as well because this looks like a disaster waiting to happen. Okay. Good morning, Mass Mob. How are we doing? How are we doing today? I tell you what, so I'm just going to confess this from the start because I got caught out. I do a little lesson on Zoom before this. Well, yeah, it's a nice little group of people that I've been with for like a couple of years. No, not a couple, about a year now. But no, yeah. I got caught out because I put a jumper on to look professional. Yeah, look at me, all professional. But I was still in my pajama bottoms. Look at this. I didn't get fully dressed and I had to turn my camera around. I was like, been caught. So I'll just confess from the start. So I'm going climbing later, so I was like, I can't be bothered to put like jeans on just to get into climbing stuff afterwards. So I thought I'll just stick with my pajamas. How are you doing this morning? It is Friday. Whoop, whoop, whoop. Love a Friday. I don't know why I love a Friday so much because I work over the weekend, so it's not like it signals the weekend for me, but I do. I just love a Friday. It's got that vibe to it. How are you guys doing? There's a hi on Facebook. If you want to say hi, I'll come to it at the end. But yeah, I'm going to say it. There's a couple of people on there already that have jumped in early on, which is amazing. Today we are looking at build battles. So I loved planning this one so much. Me and my son hid away doing this for ages, and we promised we were supposed to come back, and then we were super late because we got too into it. Excuse me, but it was really cool. So we're looking at build battles and using that to explore scale models if you want to. How was I going to start this one? Let me just remind myself. I have taught this lesson, but my brain just not all there this week. This week's been one of those ones where your brain just sort of, I usually this is a good way to explain it. Usually my brain is like, boom, boom, boom. I love speed, everything fast. And this morning things are just going slow. So, we'll go with what the brain says and I'll slow down. What is a build battle? I better introduce that first. Okay, so a build battle. A build battle is when you decide on something to build. So this can be in Minecraft. It doesn't have to be. It could be with like junk modeling. It could be with Lego. It could be with absolutely anything. But we did it on Minecraft. And you come up with something. So our build battle was for sheep houses. So we want to make houses that look like sheep, not houses for sheep. I think that's the only other way you could interpret that. Yeah, houses for people that look like sheep. So sheep houses. But then you need a criteria for judging it. Maybe Maybe. Do you? I don't know. Do you? We didn't actually like judge ours. We just had a laugh with it. So you can do winners if you want to. But if you're going to do that, you need criteria beforehand. You can't just make it up afterwards, can you? That doesn't seem very fair. So that's the first thing I was going to look at, is a scoring system. What sort of things could you put in your scoring system? So I'm going to give you like, I don't know. I was going to give a time there, but I'm going to just say like the amount of time I can manage to be quiet for to come up with some ideas that you would use for a scoring system. And then I'm going to use my ideas and ones people gave me on Facebook, because I can't see comments during this lesson, to feed back to you on a scoring system. So have a little think. I'm going to turn you around because I've got a PowerPoint, to show you. It's cool. So your scoring system, what would you score on in a build battle? What's going to be important to you, do you think? You can use my example of a sheep house if that helps, or you can think of something else you would like to create that would be really awesome. What would you score on? Have a little chat to the person in the room with you, or maybe you want to note it down or draw a little picture. Just have a little think about it. Any of those things are fine. Obviously not managing to stay quiet for very long. I'm now going to count 5 in my head with elephants being quiet. Okay, there we go. That's enough quiet. Scoring system. So what sort of things might you score on? You might think about something like, what she says, it's not working for me. Here we go. Style. Whose is the most stylish? Were you trying to build in a particular style? Who's maybe jazzed it up a little bit? What else might you think about? Accuracy. So we're going to look at that today. Precision and accuracy. Is that important? I don't know. It's up to you, isn't it, really? It's up to you how important accuracy is. Speed. Now, speed, we initially tried doing ours in a time frame. It went out the window really quickly because we just got really into it. But maybe you're having a speed build battle and speed is important. Or maybe you're building the same thing, but whoever finishes first gets like extra bonus points or something like that. Function. Like, I mean, a sheep house, it's got to look cool. It's got to look stylish. It may or may not have to be accurate, but it does need to function, doesn't it? Because if it's not a house, like, it's got to protect you from mobs, maybe have a bed to sleep in, maybe like some windows so you can actually see out of it. Otherwise, it's not a functional house, is it? And what about details? Added details I'll also come to later and see whether you think they're important or not. Can you manage detail, accuracy, style and function all at once? I don't know if I can anyway, but you have to make the decision on that. Okay, so before we go into the build battle, and I'll show you our build battle, which we haven't actually finished. If you're watching, Frank, we need to finish that build battle. I want to ask you this. If I showed you one cube, okay, single cube like that, I want to double the size of this cube, okay? I want to double size of this cube. How many cubes do I need to do that? I want to retain the shape. I want it to be a cube, so I'm going to enlarge it. I'm going to enlarge this cube by something called a scale factor, but I'm going to essentially double it. I'm going to enlarge it. I want to double it. How many cubes will I need? Now, I wasn't very precise with my language last time, which caused a little bit of confusion with this. I'm asking how many cubes I'll need in total rather than how many extra cubes. So including this single one, if I was going to start enlarging this around it, how many cubes would I need including this cube? Okay, so I'm gonna like start building around this one. Have a little think. Have a little think about it. What do you reckon? What do you think? I mean, when we're doubling something, usually the automatic thing would be to double it, to have 2 of them, wouldn't it? So if we put a second one on, let's see what happens. What's happened there? I've definitely doubled the size of it. I've doubled something called the volume of it. So the volume of something is a quick way to explain volume. If you've got like a container, like a cup or a jug or a bottle or something like this, the volume is how much stuff fits inside of it. So I could fill this up with water and measure how much water's in there, and that will be the volume of it. So the volume is how much stuff fits inside of something. Okay, so I've doubled the volume there because I've got double the amount of plastic, I guess, here. But it's not a cube. It's not a cube anymore, is it? What we've got there is, you might call it an oblong, or if you're going to be super accurate, a cuboid, because it's still a square at one end. But on the side here, we've now got a rectangle. Do you see that? So that's a rectangle now. And if I'm looking at a cube, I want all the faces to actually be squares. So you might think, well, let's double it again then. I'll double it again. If I double it again, aha, I've solved a problem. I now have a square at the front. But when I turn it to the side, now that's a rectangle. So still not a cube. Still not a cube. Okay, so let's take this side here. Let's double that and make that a square. So now I've got a square on all those faces around the edge. So we've got the front and the back, and the two sides are both a square. And the top's a square and the bottom's a square. So now every side, every face, I should call it, is a square. So I've created a cube, but that doesn't, it's not double the volume, that one. It's actually, it's a bit of a confusing one. I purposely worded the question really ambiguously, because doubling the size can mean lots of different things. We could double the length of something, we can double the area of something, and we can double the volume of something. So I'll try and show you that in a different way using my PowerPoint. Okay, let's have a little look. Let's have a little look. See. Oh man, I'm in webcam here. There we go. There we go. Right. Here we go. So I started with a single block. If I double that block, so I take two of them, I've doubled the length. You can see this yellow area here, this yellow side. What I've done is I've doubled the length there. So I'm going to call that the width. I've doubled the width of my square. So I've now doubled the width. The problem is that's no longer a cube. Now I'm going to double the height. So I've taken the blue side and I've doubled that. I've doubled that. I've doubled the height. But still, we haven't got a cube. So now I need to double the red side, which is the top in this case, to take it, and I've doubled the depth of it. So when we're doubling something or enlarging something in 3 dimensions, we have to think about all 3 dimensions. We have to think about the width, so doubling the width, doubling the length, or the height, sorry. So I'll go back. Double the width, double the height, and double the depth. So I'm doubling it 3 times. So actually, in that case, I've taken one single cube. In this case, I've taken one single cube. I've now added loads to it. Give me a sec. I took one single cube. I doubled it to give me 2 cubes. I doubled that to give me 4 cubes, and I doubled that, and they ended up needing 8 cubes to double all of the measurements that I needed to in this case. And that's keeping it to scale, i.e. I've doubled every measurement. So I've doubled all 3 of the measurements that we need to measure that, and that keeps it to scale. Do you want to keep it to the scale all the time? Don't know. We'll discuss that later. There are different options, definitely. So another way I wanted to show you this, I said bring with you a tape measure or a ruler. So I'm going to grab my tape measure, which I forgot to grab. Give me one sec. So tape measure measures length. So this is just one dimension. So if you pull out your tape, if you've got a tape measure, pull it out. If you've got a ruler, you can just point to the length on there. So if you can find 10 centimeters, 10 centimeters. So on mine, I pull it out to the number 10. Oh, it's not very good. It's a bit worn away, this one. Pull it out to the number 10. Now, if I want to double that length, how far would I need to pull this out? So I want to double the length 10 centimeters. How far am I going to need to pull this tape measure out? On a ruler, you'll just have to move your finger along further. What number will you have to move that to? How far will you have to pull it? So because it is just a length, I literally just double the number. I double the number 10 to 20. So I've doubled that length of it. That's just one single dimension. Now let's have a look at something like area. So area is where you've got two dimensions. So I'm going to use a square in this case. If you've got a piece of paper, grab a piece of paper. I think I said to bring a few pieces of paper. It doesn't have to be a square. It can be a rectangle too. Whatever you've got is absolutely fine. So if you place your piece of paper down on the floor in front of you, place it down in front of you. And, oh, that wasn't what I expected. That went a bit whizzy, didn't it? Whoop, whoop. So paste that down in front of you. And now we want to double this and keep it as a square or a rectangle. So you want to keep the same proportions of this shape. And I want to enlarge it or make it bigger by something called a scale factor of 2. So that means I'm not going to double the area. I'm going to think, because if I doubled the area, what would happen is similar to before with my cubes. I don't end up with the same shape. I've taken mine from a square and I've made it into a rectangle. So now I've just doubled the length in this case. So I've doubled how long it is. If I wanted to double every dimension, how many of these pieces of paper am I going to need? You have a little explore with yours. You'll have different size pieces of paper. That's absolutely fine. Or you might not. You might have square pieces of paper in front of you. How are you going to retain the shape? So keep it as a square or a rectangle that's the same proportions as you started with. Have a little play. Maybe you've spotted the same as me. I'm trying to pick two pieces of paper that are different colours here. But actually, I've doubled the length, but I also need to double the width. But that's no good just doubling that bit, because then I've got a gap here. I actually need a fourth piece of paper in order to do that. So I needed to double it once and then double it twice. So I end up actually making the area 4 times bigger. I started with one of these sheets and now I've got 4. And then finally, volume is what we were exploring with the cubes, where when I'm doubling my volume, I started with 1 cube. Sorry, not doubling my volume. I apologize. If I am enlarging this by a scale factor of 2, I am actually going to have to double the length. Then I have to double the height. And then I will also have to double the depth. So I have to double it 3 times. So I end up actually making it 8 times bigger, the volume. So when you're enlarging things, it's not as straightforward as just doubling or multiplying by 3 or something like that. You have to think about all the different dimensions and all the different measurements and making sure you're doing all of them equally. Otherwise, you'll end up like making the shape a little bit strange or stretching the shape in some way. How does this relate to our build battles then? Okay, so there's a few different methods you could use for enlarging something when you're doing a build battle. Okay, so I've shown one here. I built a torch. I built an enlarged torch. So here's an original torch. This is a zoomed in version of it, and you can see here that it's not made up of full blocks in Minecraft. Minecraft blocks are a particular size. These little squares are much smaller. So all I did with my enlarged version is for every single one of the little blocks, I replaced it with a bigger block that was a similar colour. So where I could see some dark brown, I replaced it with a dark brown block that was bigger. So I've replaced each of these tiny blocks with still a single block, but a bigger block. And you can probably just see down there. This picture's not brilliant actually. There's the tiny little torch and there's my massive one next to it. So one way of making something larger is literally to take bigger versions of everything and build with the bigger versions, replacing like for like. So if I had a bigger pink cube and a bigger white cube, I would just attach those together and it would be a bigger version of this. But life's not always that simple. You can't always just find a bigger version of something to attach it together. So sometimes you have to think about other ways to do it. So this is where I want to show you our sheep house build battles. So with the sheep, we didn't actually mean just regular sheep. We specifically meant Minecraft sheep. So we were looking at making it look like a Minecraft sheep. This picture's from the same website I used last week for the top trumps, Minecraft Wiki. It's a really good website for if you want pictures or statistics about Minecraft. Absolutely brilliant. I'd recommend it. So we wanted to build a Minecraft sheep house. I have to give you a couple of top tips from my son, first of all, that were really, really useful. So the first top tip is to build a massive wall between your two build battles, bigger than you think. Okay, we built one that I thought was massive and we ended up being able to see each other over the top of it. Somebody suggested when I was doing this on Facebook to go to the build limit with you all. Probably a good idea. Probably a good idea. You want to be able to walk around the front because eventually you want to be able to see each other. So I suppose you could just smash the wall if you needed to. But yeah, you want to build it bigger than you think. The other thing that I thought was really, really cool idea was rather than just having one idea, we actually had 5 ideas for build battles. In our heads, we were going to be really quick at this, and we just weren't. That just didn't happen. And we were going to do multiple build battles. So we had 5 different ideas, and my son showed me how to create a random build battle generator, which was cool because then it meant that like you could have multiple different ideas. Everyone could give an idea, and we could, generate a random option. So he did that with an anvil and then some paper, and he renamed the pieces of paper. I can't remember what our ideas were now. I can't remember them all, but one of them was the sheep house. Put the paper inside a dispenser box with a button on it, and then you press the button and it dispenses a piece of paper that's labeled with your build battle. I thought that was a really cool idea anyway. So this leads me to method 2. Is estimating. So estimating is what we used here. We didn't take exact measurements. We did have pictures of Minecraft sheep that we could refer to, but we were estimating. Okay, so you can see we didn't quite finish fully our sheep build battles, but you can probably also see some other things about our build battles here. So we've got 2 different sheep houses. I went for traditional white. My son went for this lovely blue. Is it blue or has it got a special name? I can't remember what the name is. And I asked this on Facebook the other day and I've still forgotten what the name is. It's got a special name. Is it aqua? I can't remember. It's not the rarest sheep. I did find that one out. The rarest is pink. But yeah, we went for different coloured walls. So we did go for different colour walls. But maybe some other things might stand out to you about this. So if you look at our sheep, are they the same size as each other? Have we used the same dimensions and the same sizes as each other? Now I'm looking at this thinking it's maybe a little bit dark. No, I'm hoping you can see that okay. It's going to be the best I can do. Have we used the same dimensions? Some things that stand out to me here is that both our sheep, they're the same height as each other, aren't they? They are the same height. But you can probably tell that we've not taken accurate measurements because, for example, the legs are not the same size as each other. They are not the same size. We've got different size legs despite having the same height houses. So we've stretched our sheep a little bit in different directions. Also, the faces are different sizes to each other. The face at the front is a different size. So we've used different ways of making our faces larger. Now, we also, I was a little bit faster at this. I did this a little bit speedier. But this is what I meant about what is worth more, speed or detail, because my little legs didn't leave for much detail. Whereas my son's legs, because he did them wider, he was able to add detail like the hooves to them, which I actually thought was really nice. And I regretted not doing. But it was too late, you know, by the end, I couldn't just cheat and go back and change it, could I? So they're the first two methods. So one is just to take a block and make the same object, but with bigger blocks. The second one is estimating, but as you can see, you'll get different dimensions. They might look differently to each other. So one might look a little more stretched in one direction, one might look stretched in another direction. And the third method is to actually use the scales we were talking about before and thinking about multiplying everything by the same amount. So we were talking before about doubling everything. So we were timesing everything by 2. But you can do that with any value. You can make anything as big or as small as you like using this model. So the third model is called keeping something to scale or using a scale factor. You don't need to necessarily remember those words, but I like to introduce mathematical words so that if you hear them, you're like, oh, wait, I've heard that before, because it doesn't come up in everyday life all the time. And it can be confusing. So I've got a picture of Maths Mob Monkey here. So can you see Maths Mob Monkey? Maths Mob Monkey is just here. And I asked you to bring along maybe a toy or a teddy with you today. Have you got a toy or teddy to hand? If you have got one, amazing. You're going to be using your toy or teddy and your tape measure or your ruler to take some measurements. Okay, you might need somewhere to note these down. So if you've got something to write with, something to write on, that could be helpful too. So the first measurement we want to take, because Maths Mob Monkey is 3-dimensional, we're going to need to take 3 measurements. And then what we're going to do is we're going to use this scale here. So this scale here is 1 to 3. That means for every 1 measurement I take, I want to enlarge it by 3. So this time, instead of doubling, I'm going to be multiplying by 3. Okay, so the first measurement I'd like you to take is the height. So the height of Maths Mob Monkey is 8 centimeters. Yours might be different. So measure the height of yours now. So if you're measuring, I'll show you what I mean by measuring the height. Measure the height and make a note of it. You can use a calculator for this too, by the way. I'm not expecting people to just do this in their head unless you really want to. So we're going from the top of Maths Mob Monkey. I'm going down. You could go down to the feet, you could go to the bum, depending on what sort of animal you're doing. I was thinking Maths Mob Monkey would be sat down, actually. But yeah, measuring the height. So that's the height, the first measurement. Make a note of that one. And then we need to know the width of your toy or teddy. So the width is going from side to side. Okay, so we're going from side to side. So you want to find the widest part on each side of your teddy or toy. So if I show you with Maths Mob Monkey again, I've got, look, you can see it's sticking out a little bit at these sides here. These are the widest parts. So I want to measure best I can from the widest part to the widest part like that. Okay, I'm realizing these measurements are nothing like the ones I've got on my screen, so I won't share those with you, but from the widest part to the widest part, that's the width. Once you've done yours, make a note of yours. Just make a little note of your measurement somewhere. So we've got the height, we've got the width, and then we need a third measurement of your toy or teddy. The third measurement is going to be the depth. How far back does it go? In this case, it's going to be how big is Maths Mob Monkey's bottom. So how far back does your toy or teddy go? So if I show you mine. So Maths Mob Monkey has got a rather generous bottom sticking out. In fact, no, it's got the tail as well. So I might need to include that. Do I include that? I'm not sure. Maybe it's just hanging down. So we want to measure from the front to the back and take a note of the depth. So that's your third measurement. Make a note of yours. So make a note of yours. So I've written my measurements on my PowerPoint, and I'll go back through those now. You might want to grab a calculator for this bit. It's up to you. Or you might be able to do this without. Whatever suits you is absolutely fine. What we're going to do is work out what the measurements would be if we were to enlarge your toy or teddy by this scale factor here, by a scale factor of 3. So if I go back through mine, for Maths Mob Monkey, the height, the original height, I am saying was 8 centimeters. But I need to multiply that height by 3. So I'm going to do 8 times 3. So the height becomes 24 centimeters. So my new height of my enlarged monkey would be 24 centimeters. Can you see that? I don't know if I've got that on the screen well enough. Let me move it back a little bit. There we go. Then I'm going to take, so you do the same. Take yours, enlarge it by a scale factor of 3. Work out what that multiplied by 3 would be. Then we're going to take the width. So the width of mine was 2.5 centimeters. And I need to enlarge this by a scale factor of 3. So I'm going to do 2.5 multiplied by 3, which gives me 7.5 centimeters for my width. And you can do that for your toy or teddy. What would be the width if you enlarged yours by a scale factor of 3? And then we need to take the third measurement, the depth, and we're going to enlarge that by a scale factor of 3. So I've got my depth as being 2 centimeters. So I'm going to take that and multiply that by 3 to get my depth of 6 centimeters. So my enlarged Maths Mob Monkey, instead of being 8 by 2.5 by 2, would be 24 by 7.5 by 6 in terms of height, width, and depth. I'm going to give you a second just to finish doing yours and making a note of yours. So with 3 dimensions, if we're doing it to scale, we're going to have 3 measurements. We're going to do a little quiz now. So I'm going to put up, what I showed you there was a ratio. The 1 to 3 was a ratio. So for every 1 in real life, I was enlarging it by 3. So I was multiplying by 3. And this quiz is just what would you multiply by? You can write it down if you want to, or you can just shout it out. You can just think it. You can do whatever you want. Tell the person next to you, whatever suits you. What would I multiply by? So I'm enlarging by these scale factors. I want to know what I'm going to multiply each of my lengths by. Okay, are you ready? First question on its way. So the first one, 1 to 8. What would I multiply by? What would I multiply by? Did you say 8? Yes, we would multiply by 8. We would multiply length, width, and height by 8. What about this one? 1 to 4. What would I multiply by? What would I multiply by? Are you saying 4? Are you saying you would multiply by 4? Yes, that is it. Multiply by 4. What about this one? If I'm enlarging by a scale factor of 3.5, what would I multiply by? What would I multiply by? Are you saying 3.5? Absolutely. We would multiply the height, the width, and the length all by 3.5. What about this one? 50,000. Has anyone seen this one? I don't know if anyone would recognize this number. If I want to enlarge by a scale factor of 50,000, what would I multiply by? I would, in fact, multiply the length, the width, and the height all by 50,000. This one, it's not a random number. This 50,000 is a really common scale that you see on maps. We live very close to the Lake District, and we have some famous maps. Famous maps? What are they called? OS maps on the wall in our living room. And they're of a scale 1 to 50,000. So for every 1 centimetre on the map, it represents 50,000 centimetres in real life to keep it to scale. So yeah, that's not a random number. That one's one that's used really frequently in real life. And then I think I've got one more. Got one more on here. 0.5. What if I was doing it to a scale of 0.5? You are spot on. We would multiply the length, the width, and the height by 0.5. And actually, people noticed on Facebook, somebody commented that actually what happens when you multiply by 0.5 is the numbers get smaller. So this one, it's bizarre in maths. It's called an enlargement, but it's actually going to get smaller. Everything's going to get littler, but it's still called an enlargement. Confusing. I know. It just means like a change in size in maths. Okay. That is all I'm doing for today. That's what we're doing in terms of scale models and build battles. Thank you ever so much for joining me. If you've joined me live or if you're watching the recording, that's awesome too. If you are enjoying these and you feel that you are able to pay, then I do have a couple of little memberships, one for £5 a month or £6 a month, just to pay my wage for these. So at the moment, if you pay £5 a month, you get the Maths Mob memo, which says Maths Mob Momo, because I'm awful at spelling, through the post, with some origami paper and some stickers. What stickers have I got to show you? I've got I love maths, and you become a member of the Maths Mob. If you pay for £6 a month, you get that through the post, as well as you get workbooks you can print off every single one of my sessions that I do. And I'm currently, if you're into Maths in Nature, if lots of people have asked about Maths in Nature, I'm currently working on a little, I don't want to call it a magazine because people will compare it to Theatre of Science, and it's just, it's a maths activity book. It's got lots of puzzles, problems, and practical activities you can do at home, all to do with maths. I've not come up with a better name than the Maths Mob memo yet, but I'm working on one, all to do with fractals, very naturey, very arty. Yeah, if you're into math, art and nature, definitely up your street. So I'm working on that, hoping to get that out very, very soon. I said I would say hi to people. If you've not had a chance yet, head to Facebook. There's a post on there that is a mess because me and Canva big time fell out this morning. That says comment here. You can still put a comment there. I'm going to read out the ones that are there already, and then if I'll refresh. So if you do another comment, that's fine. Okay, but I'll tell you when I refresh, because then don't comment after that. Okay, so the comments I can see already. Let's go. I saw some comments before I started. Who have we got? Hi, Sophie, Emily, Katie, and Hannah. Wow, and also your new teddy, Millie, who you got yesterday after our lifeboat station tour. Oh, and she's letting you measure her. That's so cool, guys. I'm going to show everyone your awesome teddy. Can you see the little, oh man, I've accidentally pressed something. Didn't mean to. Can you see the lifeboat teddy, Millie? Millie looks very cool. Millie, you are ace. And so are the rest of you, Sophie, Emily, Katie, and Hannah. Thank you for sharing that with us. Isaac and Serena excited to build battle for the rest of the day, having had a double whammy with Theatre of Science and now Joyful Maths with Ruth. Amazing. I am so glad. My kids have done the same. My kids have had exactly the same morning with their dad downstairs. So yeah, it must just be the perfect morning, I think. It must be. Evie's here and saying hi, has an entire box of Lego ready. Wow, Evie, that's epic. I would love to see some of the things. Did you manage to create cubes with Lego? It's quite hard, isn't it? You need like multiple. I should maybe have been more explicit about that. I love using Lego, but it's annoying because we don't have cube blocks. Do they exist? Can you get cube blocks in Lego? I don't know. Somebody tell me. I would like to know. Imogen and Ophelia, it's your first live lesson. Woohoo! Go Imogen, go Ophelia, go there, Mum, for getting them here. I've assumed, Mum, I was right, I think. Woohoo! Oh, Matilda, nice to see you too. I hope, if you're still having issues getting the workbooks, give me an email, please. That's very, very easy fix. I can definitely 100% fix that. Very, very easily. Nice to have you live with us. Hi, Laurie. Hi. Did I say a big hi? I was trying to say a big hi. I was trying to say a big hi on Facebook. Hi, Jacob. Nice to have you here too. Thanks for joining. Oh, Pamela. That is a very exciting comment. Loves, thumbs up, smiles, rainbows, and even some little, are the gifts there because they're cube shape? Is that just how my brain works, or is that how your brain works too? I'm hoping it's because they're cubes. I'm hoping so. Right, I'm just going to do a quick refresh just to make sure I've said hi to everyone because it's super special. Oh, I should say hi to my kids too. Hi, my kids. Thanks for joining me. Thanks for helping me plan as well. I really appreciate that. Let's just have a quick look. Oh, Pamela, Evie, you really love my videos. Oh, thanks, Evie. Oh, my phone's singing at me. Don't know why. Oh, I'm so pleased you love them, Evie. I love doing them. I really do. It's like the best job. It really is. I've got to say thank you for Laura for like coming up with this job. Like I've taught live lessons online for a while, but the idea of how her format is just spot on, in my opinion. Absolutely spot on. Oh, hello from Bella. Hi, Bella. You and your mum were on Minecraft for over an hour before the lesson building a Roman villa. What? That's so cool. So you've combined the Roman villa from Theatre of Science and the Minecraft in maths, and now you're doing a build battle with your friend. Oh my gosh. Like, just big love. Big love. That sounds epic. Oh, you have so many questions, Pamela. Okay, yeah, ask away. I love questions. I love them because I can't always envisage the questions people want to ask. So it helps me. It helps me when people ask questions. Who else have we got? Timothy, Noah, Joseph, and Julietta. Hi, guys. Thank you so much for coming. It's awesome to have you guys here too. Oh, Jake and Charlie are watching live again. Awesome. Hi, Jake and Charlie, I should say. Yeah, Frank and Effie have really loved playing Minecraft with you. They have really loved playing Minecraft with you, Evie. I think it was mostly Frank. Oh, cool. Okay. Have you got like a cube brick there? I'm looking at this. Okay, so this is my question to you. If you measure that brick, okay, it's hard to tell from the photo. Is it the same? Is it a square on the side? Because none of mine are. But I've got my Lego's a bit rubbish. My son got annoyed with me borrowing his, so I had to buy my own, and it's a bit rubbish. So that's why I want to know: is it a square on the side? Because if that's what you've got, I don't have those. I don't have any of those ones. That's the problem I have. I think I've hit everyone. I hope so. I really hope so. Yeah, I'm not going to refresh again now. But if you say hi, I try to comment back. Sometimes comments and things go a bit mental, and you don't mean to miss people. It's just that like the notifications go a bit mad, and it's really hard to keep up with them. But yeah, I try my hardest because I so appreciate you guys joining so much, so much. Thank you so much for joining me. Thank you if you're watching the replay. I will be with you again next week doing Minecraft time, because Minecraft time is a strange thing. And then we're going to have half term where I sort of take a week off, but I don't. I work. It's just not live on a camera. And then we'll be back doing Maths in Space. I totally gave you all free choice on Maths in Space, definitely, but I think you're with me. Right, bye guys. I'm gonna go climbing. Bye. Thank you for joining.